So let's get started today. Thanks, everybody. I know I have the after lunch session, so that's always a difficult one. I will try to keep it as upbeat as possible in case your food coma commences. So today, the presentation I'm going to give is on JavaScript and accessibility, JavaScript for everyone. A little bit about myself. My name is Sean Brackett. I'm the lead front-end developer at Forum 1 Communications. Some things about me. I wear a lot of hats. Literally speaking, I tend to wear hats all the time. And then another thing is that before I got into front-end development, I was a classical printmaker. So if anybody wants to discuss lithographic techniques of the 19th century, I'm happy to do so after the presentation. I work at Forum 1 Communications. We are a full-service digital agency that works with mission-driven organizations to create stunning designs, smart messaging, and custom-built technologies, mainly like open-source stuff, Drupal, WordPress, and then other things that we're taking on right now, like static site generation stuff. We help them realize their goals and extend their influence in areas they care about most. Here's a list of some of the clients that we work with. I should mention that a lot of these clients, we have done some accessibility work, audits, designing for and improving accessibility, and then doing some maintenance work to improve accessibility of pre-built widgets and things like that. Grab a seat. All right, so JavaScript for everybody. Building for inclusion. I want to start today by sharing with you a story, and it's something that I came across doing some of the research for this presentation. There's this couple in Brazil, and they're expecting their first kid. And so I want to preface the story by this is all going to end up well. It's a good story. There's nothing bad is about to happen. So this is a great story. So they're expecting their first child, and for some of you that have children or are thinking about having children, like one of the things that you do is you go in for a sonogram. It's kind of a cool thing. Eventually later on in the pregnancy, you actually get to see your kid in a 3D model. It's printed out. It's kind of awesome. You put it in the fridge. You share it with your friends. Take iPhone photos of it. Great. This couple in Brazil, things are a little different for them because both of them are legally blind. So they can't actually experience that same sort of intimacy of seeing the photo, getting the printout, sharing it with their family and friends. However, their doctor is able to leverage technology, specifically 3D printing, to take that 3D model and be able to print out a 3D model for them to actually touch. And so this couple, one of the quotes that she had, so this is an example of that. They're actually holding the model there, and they've done it at different points in time in the pregnancy to be able to share that experience. So when she talked about this experience, the mother, her name is Ana Paula, she describes it as, thanks to the exams and the printing, we were able to not only know that our baby was growing healthy, but also to have a very real contact and establish a very strong involvement with our son. And that's kind of an awesome story, and we don't really think about when we build things or when we do things, how it impacts people. And so to me, this story demonstrates a couple of things, and I'll get into those in a second. But one of the other things that came out of this is that doctors are now able to use this technology in other ways as well. So they use it to train other doctors as they prepare for prenatal surgery. They use it to explain to sighted people what kind of congenital disorders and how they may affect their child. So this technology that was used to sort of enhance an experience for a non-sighted person sort of benefits a broader swath of people. So this story to me demonstrates a couple of things. The first one is that inclusive design has real human impact. It empowers people, and this is both in sort of product design, but also in web design. It empowers people. It gives them freedom. It gives them access. So whether you're working on, say, a government site where somebody needs to go and get critical information on a timely basis, that's important. It allows people to have privacy. So if you are someone that needs to access your medical records and the website that you go to isn't accessible, that person now needs to have somebody else come in to sort of help them go through the process, and they have to release some of their privacy to do that. It gives people access, again, to things like just shopping, buying something on Amazon. And, in this example, it gives people the ability to have that tactile experience to touch their soon-to-be first child. The second thing that inclusive design does is just good design. Inclusive experiences improve the experience for all users. So how many of you have been somewhere in a poor lit situation, you pull out your phone and you're trying to read the text, and it's really important, you need to get this information, and somebody has designed this website with really skinny, weighted fonts, and you can't see anything. That's a really annoying situation. And that's bad for you, and it's bad for a person that may not have the vision that you have. Or if you've ever been in a bar, and one of your friends sends you a YouTube link, and you want to watch the video in the loud bar, captioning is something that we all benefit from, but really it began as a means for non-auditory people to be able to experience video information. So there's this front-end developer that I follow a lot, Chris Demars. He's really big into web accessibility, and in one of his talks, he shares this definition of what web accessibility is. And to him, he describes web accessibility means that everyone can use the web. And that's awesome, because everyone should be able to use the web. And as developers, I know, because I've sort of fallen into this trap myself, it's just really hard to focus on your needs. Like, your need to actually get this done within the time of the sprint. Like, it has to get done. These features have to get done. Your need and your desire to, do the next, push the envelope, to do the next sort of cutting-edge thing, to pull that next shiny thing and put it in a new feature or a website that you're building. And with JavaScript, there's literally a new shiny thing every week. Like, I have a package manager for my package manager. I'm running, a bunch of CI stuff. There's Node, there's Grunt, there's Gulp. There's all these different things. And in the past years, JavaScript has really exploded. We have JavaScript in our browser. We have JavaScript on our servers. We have JavaScript on your desktop in the form of Electron apps. And it allows us to create some really, really incredible stuff. If you're using React, you can create a very custom app-like experience. If you're into storytelling, there's amazing things you can do with immersive narratives using something like a GreenSock or GreenSap. There's also things that you can do if you're telling digital stories or data stories with D3.js. But we need to do these in a way that includes all of our users. And so, in our dev den, we were having a discussion about JavaScript and accessibility, and some people believe, are on the belief that JavaScript really just isn't accessible. And I think that's a myth. JavaScript is actually not the enemy. How we use JavaScript is the problem in most cases. And so today I'm going to talk about some different ways and some different techniques we can think about as we start building some of these applications to be able to make these things more accessible. Because it's really important, because it affects a large number of people. 1 in 4 U.S. adults, that's about 61 million Americans, have a disability that impacts their daily life. And these can come in many different forms. You have vision, some difficulty seeing, color blindness, low vision, sensitivity to light, sensitivity to movement. There's mobility. I'm not actually doing this in order, so bear with me. So physical mobility, which is examples of missing limbs, broken arm, holding a baby, and then cognitive things like difficulty concentrating, remembering, or making decisions. And then we have hearing or auditory issues, deaf, low hearing, ringing in ears, and noisy spaces. One thing that I will include in this is that occasionally these disabilities can be temporary. So, for example, I mentioned in the physical mobility section that you may break your arm. That is a temporary situation. Your arm will most likely heal. But when your arm is broken, you may have to navigate your keyboard. You may have to navigate in a different way that you normally can't, are not accustomed to. So your experiences you should still be able to experience the web even though you broke your arm. So, 5. I'm really into clickbait things where you sort of number the really important things, 10 things to do here, 5 things to do here. So today I have 5 things that we're going to talk about to improve the accessibility of your JavaScript. All right, the first one. Is everybody ready? All right, go. The first one is easy. It's just about starting now, starting today. So if you are working on a project and your project manager comes into the room and it's 3 days before launch and they're like, hey, how accessible is the site? That's a problem. I like to think of it like architecture. So if you get really good plans to build a building, then you're probably not going to have that many issues. But if you get pretty crappy plans and then at the end they're like, hey, we need to actually move this wall to the other side of the room, it's going to be more expensive, it's going to be costly, and you're probably not going to do it right. So we should start thinking about accessibility early, and we should start thinking about it not just as developers, but as a whole team. Because a lot of the things that you're going to inherit a lot from obviously UX and design and the workflows and all these other things, you have to sort of bake that stuff in and think about them before you actually start coding. Number 2, it's all about the markup. So the first step in actually making an accessible JavaScript application or including JavaScript on your site has absolutely nothing to do with JavaScript. It's really just about the markup. So at the end of the day, whether you are using jQuery or you're using the virtual DOM with React, your users are just going to experience markup. It's going to be divs, it's going to be p tags, it's going to be different like form elements that they'll click on and interact with your code. But at the end of the day, it's still just markup. You often hear this term semantic markup. What does that actually mean? I wasn't really sure. I kind of gave some pseudo answers. Oh, semantic markup. Use a section and use this tag and then semantic. That's actually a limited answer for something that's a little bit more complex and related to the most important thing about what we do, which is when we'll talk about that is how we make things accessible for assistive technologies. So before we get into sort of what is semantic markup, a word that you may hear in relation to semantic markup are affordances. Affordances are kind of like the visual cues that give you an idea of what an object does and what it's used for. So clearly, this is a mug. We all agree on that? Good. It's a mug. These are also mugs, and we know that not because I told you that they're a mug, but because you can see there's the handle, there's a large top. You're going to assume that you're going to drink something out of it. It works. We understand that those are all mugs. On the web, we may have something like buttons. Buttons come in different shapes. They may have borders. They may have gradient backgrounds. They may have other types of visual information there, arrows, icons. But we all understand visually that I can click on this and then something should happen. But what happens if you can't see? What are the then clues that you know from an interface that this is going to do something? And that essentially is semantics. Semantics provides a meaning beyond the visual presentation. It captures information about what a tag is, the content that that tag may contain, and then how a user can interact with it. Assistive technologies require this information to provide users alternate ways to interact with your UI. All right, so let's talk a little bit about assistive technologies. They come in many forms to meet the needs of different types of users. So you'll see things like a Braille machine, which is up at the top left corner here, or top right corner, sorry. Basically, this will relay content via several raised rounded pins that a blind person can sort of feel and interact and read content from your UI. There are screen readers, which we all kind of know. If you're on a Mac, things like VoiceOver is a typical screen reader, and that will read the information aloud to a user. And then there are SIF and puff machines. These use air pressure, the act of either sipping or puffing to send signals to a device. And these machines are generally used by people that don't have the ability to use their hands. So all of these things share one thing in common, and it's that they interact with your browser in more or less the same way. And they interact with your browser, and they don't read the DOM directly. Instead, they use something called the accessibility tree. So when you load a web page, the DOM is then translated into a tree-like structure that assistive technologies can interact with. Then the user interacts with that, and then it sends basically through an API information back through the DOM to say, hey, this person has engaged something that symbolizes a click. Do the action that your event handler calls for. So a little bit about this accessibility tree. It's not exactly like the DOM. Instead, it's a sort of a trimmed down version. It has a lot less information. It gets rid of all the stuff that we would normally use for visual presentation. But it does look at, so the DOM basically when your browser loads, it looks at this, it modifies it a little bit to send information about one, content, and most importantly, how you can actually interact with specific nodes in the DOM. So this is an example, having a general slider of what we would normally have in terms of markup. You have an input with a value of 3 and there's a max value of 5. There's a visual rendering, which your browser then interprets. Obviously, the DOM object that we're kind of used to interacting with JavaScript. And then the last item is the accessibility node. And here we're giving different values, and he's giving a role, which is describing it. It's giving the values of the min and the max. And so this can be spoken by a screen reader. So typically, when someone will navigate a UI via screen reader, you get different types of information about what a particular interactive element can do. So in this example, you're seeing a radio button, and it'll announce the name. It'll tell you the state. And then, depending on the device you're using, it'll describe the type of actions you can take. So like I said, most screen readers share the following information: role, name, value, and state. And it's really important because this happens automatically with native interactive elements. So your sliders, your inputs, buttons, all of this comes pre-baked into your form, to your form elements. So what happens when you don't use a native semantic element? This is a common anti-pattern that you may see in some JavaScript applications where you're like, hey, let's just make it a div. And we can click on it, and then we'll add an event handler to it, and it'll all work out. When a screen reader reads this, on the left-hand side here, obviously you're seeing the code. On the right-hand side, we have what actually you can look at you can look at it in Chrome, you can look at it in Firefox. This is the accessibility inspector. So what you're seeing here is that basically this is just comes out as a text element. It has no role, has no name, has no other information. So the screen reader is just going to read this as text. This gives no value other than visual representation if you styled it based on a button class. Other than that this is an interactive element. So this actually serves no purpose to the user. However, if you were to use a button, you get a whole bunch of stuff already baked in. In addition to the values of the name and the state and all these other things, browsers automatically give you keyboard interactions for free. So you can tab to a button. You can use your enter key to click on a button. And that's already baked in. If you were to use something like this in your UI, this basic div, you have to wire all that information in, as well as provide screen reader type information to the user so that they can actually know what they're interacting with, and then being able to interact with it via their assisted device. So semantic markup. These are the key things, basically using the right tool for the right job. We'll talk a little bit later about how you can actually, if in the cases where you need to be more descriptive or you can't use a native element or you need to create your own native element, how to make those things more accessible. But starting here is really the best place to go because it's going to save you a lot of time in terms of the code that you have to create to make these things more accessible. And this is a really easy win to choose the right tag when you need it. The next sort of quick, easy wins I want to talk about are, and it's all related to markup, are headings. Several people using Assistive Technology actually navigate your document via the headings. So it's really important that we, not only that in terms of the content that you're writing, that you maintain a hierarchy based on your headings, but that they are, you're not skipping headings or it makes sense to a user. The other thing that you want to think about is how you use your H1. There's some debate on what the best practice is, but more people than not, or more people using screen readers prefer that you only use a single H1 tag, and that H1 tag actually represents the document title. The other thing that's really important that sometimes happens is we use a class or we use something like the B tag to make something bold to give it a sense that it's a header. That only serves the visual hierarchies. It doesn't actually mean anything to the user. And now the user can't actually navigate the heading structure of your document because that B tag is not actual a proper tag to denote hierarchy. So just make sure that we're using the proper headers. Try to just use a single H1 tag, and then make sure that you're using, basically tags in order if you can. The next thing, let's see what we got here. I said 5 things, right? We're on 2. This is an easy one. Alt text. Use it. there's not much more to say about it, but other than that, typically the guidance is about 125 characters. You can do more or less depending on the situation, what you need to describe. Certain really decorative things that don't provide, sort of content value, you can probably use just a blank alt tag, and that's fine. Also, if you are wrapping an A tag with content inside, you have if you have an A tag with an image tag inside of it, and the A tag actually describes what's going on in the image, you may not need to include the alt tag there. You can leave it blank because the screen reader will sort of repeat the information for the user. All right, so in closing, semantic markup is key, but occasionally semantic markup is not enough. And that's where Aria comes in. So some examples. Maybe you have been given designs by your UX design team that includes an entire UI full of icon buttons. Or maybe you're using web components of some kind of other. How many people are using Angular here? All right, so if you're using Angular, occasionally you're using your own custom sort of derivative directive, and so you may need to apply some additional semantic information to it. And so this is where Aria comes in. What is Aria? Aria stands for Web Accessibility Initiative, Accessible Rich Internet Applications. It's actually a lot easier to just say why Aria, so we'll just refer to it as why Aria for the rest of the talk. It's a specification that defines a set of additional HTML attributes that can be applied to elements to provide additional semantics. So in the situation we talked about before with the markup, you saw the classic anti-button pattern where we're basically just using a div that provided no actual semantics to the markup. You can change that behavior by using Aria. However, Aria is not a magic wand. You can't just sort of sprinkle Aria attributes on all of your tags and it's going to fix your accessibility problems. In fact, misuse or overuse of Aria contributes to more accessibility issues when you're running sort of automated testing for your application. So let's talk about what these tags actually do. Aria tags, or the attribute tags, are used to modify the accessibility tree. So the thing that we were talking about before, where we're establishing, the browser basically creates an accessibility tree that the assistive technology then uses. Aria is a way for you to modify that accessibility tree. So to give something that does not have the proper semantics that it needs so that your screen reader can interact with it. It also can help you to be more descriptive if need be on a particular thing. So in this example here, we're creating a custom checkbox. That checkbox has a role. We're giving it a state because, again, screen readers are also looking at not just the role but also the state of a particular interactive element. And then we're seeing the accessibility node, basically the visual representation it doesn't really care about, but we need to translate that stuff, the other information, for a screen reader. Aria is fully supported in React, for those of you using React. And when you write it, you're going to write it with the actual hyphen in comparison to how we normally write, say, class name and things like that. Because it's an HTML attribute, it doesn't follow the same rules that we have to camel case for JavaScript. All right. So again, this is an example of our non-semantic button here, our friendly anti-button pattern. We're not seeing any information in the accessibility tree, but merely just adding the role. We now know that this is a button. It has also given us the proper Aria attributes as button, and when my screen reader goes over this, it will actually tell me that it is a button and that what the text value of that button is. And again, Aria does these things. It modifies your accessibility tree. It can provide or update semantics. It can even establish relationships between components. So, for example, let's say that you have two sibling tags, and there's a button that then controls this other widget over here to sort of open and close it. You can actually connect those two with the Aria controls value, basically saying that this item or this button will control this widget over here. Now, the support on this is not great. I think only JAWS right now supports it, or maybe one other screen reader. So with all these Aria tags, it's important that you do some research to figure out which screen readers support which tags before you use them fully in production. But it's just important to know what some of these things do. Finally, Aria can also alert the user of changes in content. So you can create Aria live regions that basically, when we change content in this div, your screen reader is always sort of monitoring these particular Aria live regions, and you can control what's called the assertiveness of those sort of warnings. So in this situation, we have an alert, but we're using Aria Live Polite. So that means that the screen reader is going to allow the user to finish a piece of content and then let them know that, hey, I need you to look at something. And this would be great for, like, let's say you have some widget on your site that is updating some news headlines or something like that. They don't need to know that it's changed in the middle of what they're doing, but it's nice to know that, hey, there's been an update. Here's the information that you may need to know. You can also use assertive, which is, basically this will interrupt a particular process and let the user know that something has changed in the site. You may want to use this if something is saved or you're getting an error message or something like that, because we need to interrupt a user to let them know this new information. So we talked about Aria, like the attributes, but Aria is actually more than the attributes. It's a sort of guidance on how an interface should perform to improve accessibility. So if you were to go to the Aria authoring practices page, and this has got a ton of stuff on it. So basically, it's going to go through a whole list of different interfaces and interactions and describe to you the best ways to make that accessible. It'll include the things like the roles you should use, the states that you may want to include on your component. And again, it also talk about the keyboard interaction. So for example, if you are creating an alert box or a dialog box, Aria's authoring practices state that the escape key should be able to close your alert box. Or if you click on the outside window, this is what should happen. So if you're coming up with some new interfaces or you're unsure about how something should work, this is a good place to start. But one thing I should point out is, again, that this guidance and the Aria attributes that are connected to these guidances don't actually do any of the interactive stuff that you would need to do in your component. You would still need to wire the event handlers and the keyboard codes so that whatever you want to happen actually does happen. So these are the things that Aria does not do. It doesn't modify appearance, so putting the role of a button on it does not make it look like a button. It basically, you still have to style it as normal. It doesn't modify behavior. So if you're not using the right tag for something, the browser isn't automatically going to give you the keyboard interactions that you would require. So for example, on a select widget, like you open up a select widget, you can use your arrows to go up and down the select widget. If you were to create a custom select widget without actually creating the JavaScript to be able to do that, then you have to create it on your own. How many people here have ever gotten a design from a designer that has a very custom select widget as opposed to the normal interface? These are the problems that we all share. So yes, this is why it's probably not a good idea, because it's going to require you to do a lot of work and a lot of testing to ensure that experience matches the native experience that a browser or a user of assistive technology would expect. And again, I've already mentioned that it does not add keyboard handling. All right, so already we're almost at 4, man. This is cool. Focus, 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 focus. You have to manage focus, because in most cases, if you're using a keyboard, that is how people are going to sort of flow through the different interactive elements of your site. And what does focus do? Focus determines where to direct keyboard events. So when you're focused on an input, basically you can start typing in that input and know that the information is going to go directly in there. And imagine if you're a non-sighted user and you're tabbing through, but you actually are a low vision user. How do you know where you're entering your keyboard events into? What happened? Could you be just giving malicious information in some other situation? You don't really know because you can't see it. So it's important that we, one, control focus, but also give people an idea of what they're focusing on. So one of the things we use to do that is tab indexing. It's a global attribute that indicates an element can receive focus. When you use an already interactive element like a button or an input, these things already come with focus enabled. But if you're using just a div or some other kind of element that's not what we would normally use for interactions, you would need to apply the tab index to it. A couple of notes on tab indexing: either set tab index to 0 or -1. The normal flow of a tab index is based on its position in the DOM. 0 will basically make anything tab index, will sort of turn on tab indexing for something. -1 will remove it from the normal flow of the tab index. So let's say you have an off-screen menu or an off-screen modal. You would want to set it to -1 because this way, as the user is tabbing through, they won't accidentally go to something off-screen that they can't see. Do not use a number greater than 1 because what will happen is then you're basically setting the order of the tabbing. And your elements could change, or you could add new elements, but that's not going to change what's going to happen in the DOM when the user tabs through. So you want to make sure that you just leave the normal flow of the tabbing as is by using either 0 or -1. Another thing, when you're laying things out, you want to make sure that if you're using grid or you're using flexbox, changing the order of something for visual presentation does not change its tab order. So if you were to move an item to the end, but then you use flexbox to move it to the first one, it's still going to go in that same order. It's going to completely ignore the visual changes that you made based on that and just go with how it appears in the DOM. This note is not just, the last one is not necessarily a tab index thing, but I think it's just really important to think about the presentation of tab. So it's really common, because designers will often ask for it, to remove the outline because they have a sort of custom design. That's totally fine if you replace it with something else, because it's just really important to know where you can focus or where the focus is as you're moving through an application. All right, so trapping focus. This is going to be interesting because I'm going to try an actual code demo for a presentation. So this could either go really well or really bad. Trap focus. So when you are in a particular situation like a modal or dialog box, you may want to trap the tab focus. So as you're tabbing through, what you don't want to have happen is the user to sort of go somewhere off screen. They haven't closed the modal yet. They don't know where their tab is, and they start typing or keying things in and nothing's happening. So trapping the focus means that basically we're going to keep the user inside the modal until they close it so that they can interact with the modal and they will always know where their focus is. All right, so we're going to try a little demo here. I wrote some code that will, here we go. Make that full screen. So this is on CodePen. I'll share it with the slides as well. So here we have this little page here, and I'm using my tab button. I'm getting an outline on my modal, and I can open it up here. And as you notice, I'm automatically focused on my subscribe button, or you can make it do anything else. And as I'm tabbing through, I'm not going back to the page. I'm staying directly in the modal. I can either click on the subscribe button to close it, or I can just click on the mask that masks the whole page. And how is this done, you ask? All right. So let's just take a quick look at the code here. So I'll point out a couple of things I think that are important. So in this document, let's go to stop. Two things I'm doing here. I am capturing key codes because it's really important to have those key codes in there. I'm assigning them some property values in there. The other thing that I'm doing is we have a open modal function. And when I open the modal, one of the first things that I do is I capture what the user was last focused on. Because this is going to allow me, once they close that modal, to bring their focus back to what they were doing before. So this is just done with basically a document active element. We give it a name, and then we've done that. All right. So tab trapping, that is going to be down in our handle down. We have an event handler that we start when we open the modal. And basically, the line 53, we capture all the possible focusable elements in our modal. We get the length, we figure out what the first one is, we figure out what the last one is. Then we decide if the user is tabbing, and they're shift tabbing, we're going to go back up the chain. If they're tabbing, we're going to go down the chain. And basically, if they're on the last modal, we make it go to the first modal. If they're on the first modal, we make it go down to the last modal, just to make sure that they keep inside the loop so that they're not escaping our modal. And then in the close dialog, basically we're just doing the reverse. We're removing all of these event handlers, and we're just removing the class that leaves the modal open. So, tab trapping. So, we talked a little bit about JavaScript in general, but I just wanted to focus on a couple of things in React specifically. Tab trapping and just monitoring where your tabbing is and the focuses of your tabbing is really important in React because of the way the virtual DOM makes the changes and then it changes the actual DOM. It's really easy for users to lose focus. So you can use the ref attribute, which is similar to the same principle that I showed you in the code example, where basically we're capturing the last thing that triggered an event in the DOM and then passing the focus back to that reference after something happens, whether after a component did mount or there's some other kind of UI change, we can then put the user back where they started. If you're going to use a modal and you're not rolling your own, React Modal is a really great tool. It's got a lot of options and it just creates a really nice accessible modal. For things like single page applications, I recommend Reach Router because there's a lot of accessibility baked in. So if you are using a single page application, typically there's no page refresh. And so on page refresh, screen readers will announce as the page refresh. It'll tell you what the new page title is and then put you at the top of the document again. What Reach Router does is it does a lot of some of the stuff for you because obviously if you're using a React application, there's no page refresh. So what it does is it updates the browser navigation. It also updates the content, but then it puts the user at the topmost section of the application so that they know that they're starting a new content. All right, so this brings us to number 5, testing. Testing, is really important. I recommend testing throughout. We're going to talk about a couple of things regarding testing. One I think is just really important, which is just linting. So setting up proper linting in your environment, because this allows you just to catch a bunch of stuff before you even deploy the code. So just analyzes the source code. Depending on your setup, your linting can sort of kill your development builds, and so you can work to fix them. Anybody here on VS Code? VS Code fans? Yes. VS Code is really great if you're writing JavaScript. The ecosystem for the plugins is awesome. One of the tools that we use at Forum 1 internally is a lot of like ESLinting as an actual plugin for VS Code. It'll catch these errors and show them to you and give you sort of context of why it's an error, which is great. And then using the ESLint plugin for JSX will actually give you a lot of errors that are sort of based on accessibility. Like it'll point out where you didn't put effective alt tags. It may point out things around your headers and stuff like that. You can also control the level of the strictness, I guess, of those rules, and so based on what you need to support. The final one, which is React Axe. I'll talk about that a little later. Actually, we can go through the slides. So this is just an example of JSX A11Y working in the browser, working in VS Code, where it's basically pointing out that this image tag does not have an alt tag in there. It gives you the problem. It tells you what a possible quick fix is. This is actually pretty cool because this, going back to that same pattern we were talking about, where you're using a non-semantic element to perform an action. This actually looks at the code and notices that I have created an on-click event, but I did not provide a proper keyboard handler. So it's going to point some of these things out based on the strictness that you set it to. But these are really great because you can, like I said, catch these errors before you even get out to production. The last one I want to talk about is React Axe. Axe is great. It's a series of different utilities created by DQ Labs. Axe, they're mainly focused on accessibility. Their sort of Axe core is actually what drives Google Lighthouse. So if you've ever done a Google Lighthouse crawl of a site and you get the accessibility information, this is actually powered by React, or just Axe in general. So there's the Axe core, there's an Axe CLI that you can run directly from your terminal. This is an example of React Axe. It's a plugin that you can use in React, and it'll run just in your development environment and give you all these console errors. Depending on the error, it may kill your build. But the one thing I really like about this is including, in addition to the errors that it gives you, it also points you to helpful information on DQ University's website about the problem that you're seeing, so that you can get information about why it's a problem, and then some information on how you can fix it. The next sort of mini topic within testing is whether you should do manual or automated testing. The short answer is you should just do both. Some things on automated testing, like obviously automated testing saves a ton of time. It can catch really common quick errors like things like missing alt tags and stuff like that. You can integrate it with your CI if you're doing continuous integration, but you can get a bunch of false positives. What the thing about manual testing is that it can get closer to understanding what the actual user's workflow is going to be. So if you have a really complicated interface where you need a user to perform a bunch of tasks, and you want to check the tab and flow, you want to make sure that they understand what some of what the actual process is going to be, and to ensure that there's enough descriptive information like within the alt tags, that is not going to be fixed by automated testing. So for example, if you have an image tag, it'll see if you have an image tag that has an alt tag, but it can't tell you whether that alt tag actually describes the image. And that's what you're going to need actual manual testing for. But it is time consuming. So, manual testing for screen readers. If you're on a Mac, definitely recommend VoiceOver. It's free and it's already on their system, so it's really cool to use. Windows users can use NV Access. And if your company can support it, you could buy JAWS and use that as well. Automated testing, I mentioned Axe from DQ Labs. There's Lighthouse, so you can use sort of web version of Lighthouse, but you can also download the NPM version of it and run it on your own system and have it sort of crawl specific pages or multiple pages. Waze is a site where you can plug your URL in there and test it that way. And then on certain projects, we've used Site Improve. This is a paid project. Site Improve is a paid product, but it's really extensive, and it gives you like some really good auditing information as well. All right. So to recap, there are 5 things. Start early in the process if you're thinking about accessibility. Critically use semantic markup. Number 3, use Aria, but only when necessary. 4, manage your focus. And then 5, always be testing. And I'll just close with saying that inclusive design is good design. Questions? All right, I'm done with it.
So you mentioned looking up which Aria tags work with what screen readers. Is there like a can I use for those?
I haven't found it, and I was looking for something like that. So what I've just done, you can just do Google searches. I think people wrote a ton of articles about, like, for example, I mentioned the control tag. A couple of years ago, there was a ton of articles saying about, this only works in this situation. And some of that changes over time. Sometimes it's best to either check with the screen reader's website, or you can look at information on Aria. But there's no can I use, unfortunately.
So you're saying we should make one?
Exactly. Yes.
You mentioned that it doesn't really matter if you're using, you had Create React App as an example, which is kind of generally used as like a single page application. Are all screen readers able to wait until the HTML renders across the board, or is that still an issue, or is it unknown?
Yeah, so at least in my interpretation of it, you would need your browser to render the DOM before it can render what's in the screen reader, because the accessibility tree comes from the DOM. So if you've ever been on, occasionally when I was doing some testing, you'll get a situation where Chrome is busy if you're using VoiceOver, If Chrome is busy, it can't tell me anything about the page because Chrome is not done sort of processing the page. So I've not seen, at least in like the testing that I've done with, like, say, VoiceOver, that I'm getting information from the accessibility tree that hasn't already been processed from the DOM.
So would it potentially be worse to have progressively rendering situation where you're delivering like the structure of the page, but the content hasn't been loaded yet?
So if that's the situation, then I think that you would want to use an Aria log region, because if you're, let's say you're doing a progressive like application, so you basically have your general page and then you're going to REST API and you're pulling something in there, you're waiting for that to happen. It may not happen immediately. You need to let your user know that something on the page has changed. So in that situation, I would put that in the Aria live region with polite, and then once, if they're reading through the document, oh, this just came in, here's something you should know about. Cool. Any more? Yes.
In your chapter example, when you didn't see it, you didn't give them a layout, right?
Well, the way out would be the exit button. So, like, basically, like in that example, it's a really simple example. I just had to subscribe, but you would have your exit button, and they would enter out there. There's some debate on whether like that's the best way to do it. I know that Google has some code that uses like an inert that basically just, you can actually render the page itself inert, and then you're just trapped in the modal that way. But then you would have access to the navigation bar. But like, if you're rolling your own, that's kind of the best way to do it.
Also with the trapping within the modal saw something else that was about like setting Aria hidden through on the rest of the body. So is that related to like screen reader reading, whereas your custom JS was just about focus?
This is just about the focus. You could potentially do that, and like. And for example, I don't remember if I did it or not, but technically the modal itself should also be a tab -0 or hidden, so that you wouldn't be able to do that. And you would change those values with JavaScript. But yeah. There's a question over there?
Yeah. So, there's various JavaScript frameworks. Do you see any one particular one has can maybe save time and effort? If your client asks implementing the JavaScript applications, I mean, but in the very high level, you haven't started anything yet. As a recommendation, when you recommend you do it, and can we give one over the others?
So, I'm used to React. I used to do Angular, but I can say very honestly, I wasn't very good at Angular. So I'm more partial to React. We use at 4.1 we use React and we use TypeScript. At the end of the day, like I said, React is just HTML, and so like you can really craft good HTML. Then it's going to be more accessible. And then like things like Reach Router make it a lot easier. There's a lot of accessibility in that. If you're using something like Gatsby, which is like React plus a static site generator, they're really big into accessibility, and they have a lot of accessibility stuff baked in to how they're building their application. But it was in terms of the time and the speed, it's whatever you're really good at. So like if you're really fast at Angular, you can make Angular accessible by like thinking about some of the things we talked about here. If you're really good at React, just keep using React. Yes.
In terms of some audio techniques that you described here, are there anything you need to think about differently for responsive design or sort of platforms, in terms of like voiceover, things like that that are different, or is it do all those frameworks kind of handle things fairly well?
So I would say that the screen readers are going to handle things fairly well. When we get into responsive design, what happens is it's important to understand how layout and source order affect what you want the user to do. So typically, like if you're working on a really complicated user interface, you want to organize the code in a way that a user is going to use it from the screen reader. Because visually, you can move things all over the place, and like we understand visually how things are going to be laid out and like what's connected to what. But if you're just sort of going through the code and the source code, you may need to reorder things there so that it makes more sense to the screen reader versus how you may actually present them. If that makes sense. Cool. Well, thanks everybody.